Good morning, dear students. We shall begin with the part 1 of today's session from the chapter Units and Measurements. In this session, we are going to deal with accuracy, precision, and errors in measurements. We know the result of every measurement by any measuring instrument contains some uncertainty, and this uncertainty can be called as the error. Coming to accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. And precision tells us to what resolution or limit the quantity is measured. For example, suppose the true value of a certain length is 2.874 centimeter. In one experiment, using a measuring instrument, the measured value is found to be 2.7 centimeter, whereas by using another instrument, the length is determined to be 2.69 centimeter. The first measurement has more accuracy because the value 2.7 is closer to the true value 2.874. But it is less precise because it has only one digit after the decimal point. But the value 2.69 is less accurate but more precise because it has got two digits after the decimal point. Coming to the concept of errors. Errors can be categorized mainly into two: systematic errors and random errors. Systematic errors are errors caused by human or instrument error which cannot be removed by repeating the experiment. It can be corrected by the calibration of the instrument. While random errors are errors in observations that vary in each experiment, and it can be corrected by multiple measurements or by using better instruments. Or in other words, the systematic errors are those errors that tend to be in one direction, either positive or negative. That is, sometimes the value will be always more than the correct value or true value, or it will be always less than the correct value or true value. Basically, the types of systematic errors are the following. First one is instrumental error, and this error arises from the errors due to imperfect design or calibration of the measuring instrument. For example, suppose if you are measuring the length of a book using meter scale, measurements which are smaller than 1 millimeter cannot be measured, and the precision of the scale is 0.1 centimeter. While if we are using a vernier caliper to measure the length, then we can get readings which are having more precision, up to 0.01 centimeter. Again, if you are using or if you are measuring the distances using screw gauge, you will be getting measurements which are more precise, that is up to 0.001 centimeter. In short, Instrumental errors occur due to the precision or calibration of the measuring instrument. Another example is the temperature graduations of a thermometer may be inadequately calibrated. That is, it may read 103 degrees centigrade at the boiling point of water, whereas the correct value that should be read is 100 degrees centigrade. Another example is in a vernier caliper, the zero mark of the vernier scale may not coincide with the zero mark of the main scale, or simply an ordinary meter scale may be worn off at one end. Vernier caliper and screw gauge will be dealing with in the laboratory sessions. Just understand the concept of vernier caliper and screw gauge. The second type of systematic error can occur due to imperfection in experimental technique or procedure. That is, to determine the temperature of a human body, a thermometer placed under the armpit will always give a temperature lower than the actual value of body temperature. Also, other external conditions such as changes in humidity, temperature, wind, velocity, etc. during the experiment may systematically affect the measurement. The third type of systematic error is personal error. Such errors arise due to an individual's bias, lack of proper setting of the apparatus, or individual's carelessness in taking observations without observing proper precautions. For example, if you by habit always hold your head a bit too far to the right while reading the position of a needle on the scale, you will introduce an error due to parallax. The second type of error is random error. As we had seen, these errors are not fixed in nature. It occurs due to sudden change in temperature and experimental conditions. These are not fixed, or the definite way of reducing random error is only awareness. And one more type of error is usually seen in measurements, which is known as least count error. Least count is the smallest value that can be measured by the measuring instrument. For example, using an ordinary scale, the least count of an ordinary scale is 1 millimeter. And least count error is the error associated with the resolution of the instrument. For example, a vernier caliper has a least count of 0.01 centimeter, whereas a spherometer will have a least count of 0.001 centimeter. And least count error belongs to the category of random errors, but within a limited size. That is, it can occur both with systematic and random errors. That is, if you are using a meter scale for the measurement of length, it may have graduations at 1 millimeter division scale spacing or interval. The figure shown is that of a vernier calipers, and we had already seen the smallest measurement which one can take in an instrument is called least count error. And least count error occurs due to defect in the measuring instruments. Hope you have understood about systematic errors and random errors, and also about accuracy and precision. Thank you, dear students.